Hello, this is your internet friend Robert Gadarian, and this is a extra video. This is not course material. I'm going to show you some cool things you can do in Python that you might want to use in your real life or for your labs in university, or just might be interesting to know. These things you can use on the final exam. If you see a time that it could be useful, I encourage you to use them. It's really cool stuff. The first thing I'm going to do, let's click on a different link here than usual, and it is called Jupyter Notebooks. These are web-based interactive computing notebook, and this is the new coolness in scientific computing. You'll see if you have a Mac that you'll get this pop-up, and that is a web server. And over in my other window, because that's exactly the experience I crave, you will get a different window, which is a file system. So this is in my user folder. I store all of my stuff in my OneDrive, and I'm going to go into teaching, and sorry, I'm talking about, we're doing 10-12. This is a lecture. This is in week 12, and this is going to be about pandas, but it's also going to be about using Jupyter Notebooks. I'm going to make a new notebook here. It's going to be a new Python 3 notebook, and this is what they look like. It's a cell, and you can change the type of the cell you have. I'm going to make this one a markdown, and I can make, this is a way of writing websites. This is a hello, and now I can type things, and I can run those cells, and this one will render into HTML, and I can include images, I can include anything I want. And then I can just write Python, import numpy as np, and then I can run that, and that cell will run. And you can see they're enumerated. There's one says 1, and now I can say np.random.randint 0 to 10, and I want size. I want 15 of these. I don't know. And then it'll give me that, and I can put more than one line in here. And I'm gonna say store this as D, and then D will print it out. Or I could say D, and I can slice this where D is greater than 5, and it'll show me that too. Well, that's nice. Then I can start just to jam on one line of code and be like, oh, I didn't get this one quite right, so I can rerun this one cell. Run. Oh, is this a rerun cell? No, this is going to restart. I've updated the interface, so I touched it last. Then I can say .sum here, and it'll give me the result of that calculation. So that's really neat. The idea here is that you're doing a lab report, and I can mix in a markdown cell and say, okay, here I need to do something. And then I can do that. So the idea is that you have your documentation right beside your code, which is right beside the results. So if you're doing a lab report that you'd usually have on paper, you can start mixing those things together, and you can have a lab report and your code and your calculations in one place. And then you can say, I'll clear it all. I want to run them all. And then I can recreate my lab result every time. And if I had some control variables up here, I could rerun my lab with different control variables, and all my code would be there, and all the documentation, all the cool stuff that I need to do this would be in one place. And that's a Jupyter Notebook. So there is slides that associate this lecture. I'm going to ignore them because I have a Jupyter Notebook that I can teach through, and it's called Pandas Examples. And it roughly follows those slides, so you can follow them along if you want. Okay. This is available to you. I will post it. It is stored as a IPyNB, Iron Python notebook officially, because Iron Python or Interactive Python notebook. That's what it is. And these there's so much cool stuff. These render on GitHub and stuff. They're kind of the best. So first, here's all my imports. I really like having them all in one place. And there's this one magic import. I'm going to make this a little bit bigger for you. Called matplotlib inline. I'm going to use plotting, so I can run that cell, and then I want to show you these things. But the actual lecture that I want to show you is how to open a spreadsheet inside of Python. And that import is called Pandas, and we import it as a stupid thing because that's what everyone does, and we're gonna do that. So let's read in a CSV. I have inside of my folder here a couple of data files that we're going to open. One of them is called class.csv, and we've opened CSVs before. It's comma separated values. Out of a class, then they have a bunch of assignments and they have a final grade. Okay, so this is what it looks like inside of Excel. So I want that, but I want it here because I want to play with that data. Python.readCSV, or PT, pandas.readCSV. And then I can simply type students and grades, and it'll show me that spreadsheet in a nice way. That's nice, isn't it? Okay, I want to know what data types it inferred. And it could, because it did infer data type, it assumed that all of these were numbers, numeric. So look at that. They're all int64. You can see that I've float 64 for the total because it is a floating point number, and that is actually correct. I'm happy about that. And the grade should be an object. And guess what? Strings are objects. So the cool thing about this is that each one of these columns is a NumPy array. Now, this is further down in here. How is this different than a matrix? So we have two-dimensional NumPy arrays. What is different about this? Well, a two-dimensional NumPy array can be exactly one data type. All integers, all floats, all objects, whatever. This one has a NumPy array for A1. This one has a NumPy array for A2. And then a different type for grade. And each one of those, you can see here, is different. So it is still a two-dimensional array, 100%. There's a certain number of rows and a certain number of columns. But we can see that there is various data types, name being notable. We can pull out a single column. There you go. I just want A1 grades. There they are. Okay, cool. How do I get the average? Well, I know it's a NumPy array. There. We have an average. What about assignment 2? There, we have an average. Done. Do you want the standard deviation? Guess what? NumPy supports standard deviation. You're done. Can we read in a spreadsheet? Well, yeah, we can. Spreadsheets are a little different because there's more than one page. So this is, you can see I have a V lookup here. It's actually a three-dimensional array because we have one dimension, two dimensions, and then we have many two dimensions. Okay, that's actually not so bad. We can work through that. All we have to do is give it a sheet name. And then it'll specify which tab we're looking at. And it'll load that in. And it'll happen super quickly. Oh, look, we read this in. It is going to be, this is approximately the same data. So I can still look at the data types. I can say students and grades. I can tab complete. I can say .head to show the first ones. And I can look at, there's actually two ways I can look at a column. I can say .a1, or I can use the dictionary style where I use square brackets. Same thing, and I'll just do it for us. Beautiful. Beautiful, beautiful, beautiful. And I can get rid of this too. I'm using all the keystrokes for this because I'm a nerd. It can't get much easier. I can fix this. Double click. Wham. Beautiful. Okay, can we create data from scratch? Yeah, of course we can. I'm going to have a loop that will create fake weather for a bunch of different cities. So I have Winnipeg, Calgary, Toronto, and Ottawa, I believe. So, oh yeah, there you go. If I run this, it's got a for loop in it. I have created a new set of a bunch of arrays. So I have dates. And if I wanted to look at dates, I could say, hey, let me see that. And it's in a list, and it's kind of super long of a bunch of dates. And then on each one of those dates, each city has, I guess, a maximum temperature. And it's some random number between, depending on where you are, minus 30 and plus 10. I'm not super positive about Canadian weather here, and that's okay. Don't worry about how I generate dates. Dates are messy. Computer science or computer programmers spend a lot of time dealing with dates. So I want to make this into what's called a Pandas data frame. And that is what this is. This is not a spreadsheet anymore. This is a Pandas data frame. And if you ever use R, it's totally the same thing. Pandas can do almost everything that R can. And R is a different programming language. You can look into it. It's rad. And there you go. Now I have all of the dates. And each one of my cities has a column, and there's temperatures on those days. That's exactly what I wanted. I'm happy. We can do some processing on this. And this is aggregation. So we have all these temperatures. That's what I made above. Dot aggregate. Look at the Winnipeg column and give me the mean, the average temperature. And there you go. It will compress that for me. It'll aggregate that data. It'll group that data and give it me for Winnipeg. Or if I want the maximum of Toronto, that's fine too. If I want the median and max, it's fine. And if I wanted to get more than one data value per city, I could do that. I believe I have to make this into a list. This is where it gets kind of messy. I'm not mead. We cannot drink mead here. There you go. Oh, it's unhappy. Oh yeah, it changes it to look like this. And that's fine. It's actually a data frame. Look at that. it renders it in a pretty way. And I didn't get the median for Toronto, so it's not a number. That's an interesting way to do it. I will get rid of that because that's kind of ugly and I don't like it. And I'm going to be posting this. There we go. If you were in the... Okay, we'll get there in a sec. You can run all this Panda stuff in Spider too. It looks nicer in Jupyter Notebooks. Okay, what if I wanted to calculate a column? So we have all these temperatures and they are in Celsius. So let's just remind ourselves what that looks like. So I'm going to say temps.head. Head will be the first 5 rows. And that's what they look like. So I want to have Winnipeg degrees in Fahrenheit. All I have to do is pretty much like a dictionary, create a new column name. And then just like NumPy, I have this NumPy array and some math on that NumPy array, and I can set it to a new field inside of my data frame. And that will create a new column. And now we have arcane units that are used in 2 countries in the world of Fahrenheit. Or maybe your parents. They might know Fahrenheit too. We can also call functions. If I create a nice, pretty little function, I can, as long as this returns a NumPy array that is the right length, I can make a new column out of it. And that all sounds kind of familiar, doesn't it? If we have a matrix, it's the exact same rules. And I'm going to say temps.head because there is no output on this one. And it's the same thing. Neat. So those are data frames. Anything you can do in an Excel spreadsheet, you can do here. But this is going to be more reproducible. The idea is that you would have raw data that you read in at the beginning, you process, and then you can see your output inside of this notebook right here, right now, and it's beautiful. But we actually want some pretty output, don't we? Okay, well, this isn't super pretty because it's really busy. Guess what? You can have plotting. All of Matplotlib. Anything you can do in Matplotlib, you can do in here. And it'll render in Notebook. And that was that special juice that I put here. I'm going to call this Python Voodoo because that's what it is. Where my Matplotlib plots will be in line here. And it's pretty busy. It's because it's just random noise. So there's no nice lines. But this has some overlapping junk. Well, yeah, Matplotlib, you can rotate the labels 270 degrees. Boom. Now they're pointing up. That looks prettier. Well, I want less data. I just want to compare Winnipeg and Toronto. Boom. Easy. So this is your X. These are the 2 Y values, which are both NumPy arrays. And we'll plot them against each other. And you can have all of the things that you have in Matplotlib where you can change the color. You can, instead of just having lines, you can have dots where there's data points. You can have X's where there's data points. You can have transparencies. You can have anything you want. It will let you do it. This is the easiest way to do it. And it's literally on that data frame, call plot. Not bad. Finally, We can make it bigger because it's a little bit small. This is the default size. We change the figure size, boom. And now it's actually readable and sensible and kind of nice. Kind of into it. Finally, I need my, there it is. I need to be able to doodle for this one. Database tables. This is where things get really wild. So if I, hey, good. Imagine a world where we had student names. I'm going to say student A, student B, student C, and then they have a bunch of grades each. This is where I would have all of the address information and anything that is about the student. So the student's data is kept in one place because we don't want data duplication because we're not animals. Then we have a different Excel spreadsheet or table that has they have student numbers. Student 2 in Comp 1012 got an A+. Student 3 in Comp 1012 got a B+. Student 1 in some other course didn't do so well. Student 2 in some other course got an F-. It has no duplication, and we have everything stored by student ID. So what we want is what's called the join, where we want student A to match anything that has ID 1. So it's going to match this. Whoop, that is an eraser. Is there an undo? I don't know how to undo. Oh, it's funny. 1. Doesn't really matter. Red, student 1 is going to match this one. Student 2 has 2 records. We want those 2 to match. As student 3 is going to match to that one. What this is called is a one-to-many relationship. And this is, although it's a third-year course, this is not actually a complicated thing. This is called a join, a one-to-many join. For every one student, there's many marks. One student takes many classes. These classes are also taken by many students. So this is actually a many-to-many. But for each student here, we can imagine it as a one-to-many. There's a lot behind that sentence that I just said, and I apologize. What does that mean to us right now? Well, we have a data set. Here's a bunch of student names. And then I give them student IDs. And there's a way to split cells. Ooh, insert. Oh, I forgot how to split a cell. It's so nice. Split. Perfect. I'll split it on my cursor. I want to see names and IDs. Dot name and ID. You can spell it wrong, but you got to spell it consistently. That is my data. I have student names and student IDs. Then I make a bunch of classes. And I have a bunch of grades. Dot head, sniff the data. We have a student ID. Student 6 took Transfiguration and Charms and got some grades. Student 5 took Defense Against the Dark Arts and got a 75. Student 2, oh my god, took Transfiguration, got a 32. Who's student 2? Hermione got a 32 in Transfiguration. Oof. She might die, or worse, be expelled. But I want to merge these because I'm a human being, and seeing number 2 for Hermione Granger is insufficient. But this is how I would want to store this. I don't want to have data duplication. If Hermione changes her name, she gets married to Ron Weasley, correct? She would be Hermione Weasley if she wanted to take his last name. Doesn't have to. I get it. And we want to change her name. Do you want to change it in 1,000 lines and potentially get it wrong? Or do you want to change it once? The answer is once. You're a lazy programmer. That's what you want to do. So we have the idea of all of the student records in one place, all the grade records in the other place. And those two things, what they have in common, are the student IDs. So what we're going to do is merge on these. So we want the student ID in our grade table to match up with any student IDs in our name and ID. And to do that, all we have to do is call merge. So we have the data frame for names and IDs. We're merging on grade table, and both of them have a column named student ID. Merge on that. And I can see the names, the student ID, and a class, and all their data. Oh, that's nice. We can get more fancy with it and be specific on left and right. That is important sometimes if the column names don't match. So now we notice that the student name is duplicated. We actually want to calculate grades per student. Okay, fine. That's great. So what we need to do is called a group by. So we want to group by the student name and the student ID because we want to show those two pieces of data. And we want to aggregate and see all of the grades for those student IDs. So any records that are Harry Potter, I want to get the average of all the grades. Hermione Granger's in here. I want to get the average of all of Hermione's records. I want etc., etc., etc. There we go. This is the entire table of their aggregated grades for all the students. So this is a beautiful thing. If you ever need a database, this is how you can do it. If you ever have two spreadsheets that you want to join on certain pieces of data, this is maybe how you want to do it. It's actually a quite beautiful thing. I'm a huge fan. I'm a huge fan of everything. And the cool thing is that you can actually run all your cells at once. I mentioned that before. They are stars because we're actually waiting for input to come. Woo! And then it'll whip through, and then there's our results again. I have some random elements in here, so all their grades changes. Hermione, 67. Her parents are going to kill her. Anyway, that is a very, very fast overview of a lot of things. The idea of a data frame and the fact that we can do aggregations on a data frame. We can do database joins on a data frame. And all of these things are actually kind of easy and quite beautiful. I advise that you try it out. In my lecture notes, there's a video to somebody who's doing approximately the same thing, but doing it in a very fast, beautiful way with stocks. And it's amazing. I should point out, what can you write here? Any line of Python. Yeah. Ask me about the big simulation I did with one of these. It took 5 hours to run. It was awesome. Anyway, I will post this. You have to open it up like you saw at the beginning of this video. Start Jupyter Notebooks and find your way to wherever you saved my IPyNV file. And then you can run this yourself, and it will just work for you. You need the data files in a data folder in the same way I do. I think I have it right here. Here's my file that I'm running. And then the data folder has to be right beside, and then it'll just rip through. Or you can just play with Harry Potter. I did that all in code, so you can just play with those. Hope you're having a good day. I'll talk to you later.